Zuzana Duchova, who is here somewhere. She asked me to substitute her because she was about to hold a lecture in Zlín, Czech Republic. And she couldn't go there, and I said, yeah, sure, I will give the lecture for you. And then she told me, yeah, but I'm going there just occasionally, and I always make really long lectures because I don't want to commute there every single week. So when I go there, it should be like 6-7 hours of teaching. I was like, yeah, but it's in 2 days, so what should I do? Eventually, she said that 5 hours of lecturing is enough. So I put together a lecture that is really 5 hours long, and I came there and I bored the students to death. But that was kind of good for me because I just collected so much material describing the computational design and what we might call digital architecture. I was showing my stuff, but basically I wanted to show a wider context. And I like speculating, and sometimes I was showing stuff that I told them that I had a couple of slides, and I had this kind of story that I told them what now I'm going to tell you is actually not true. It's not truth, but I wish it was, and this is the story that I wish it was behind the thing, because I wanted to make my point. And basically what I collected those 2 years ago were works of people I know, people who are my friends, and people I don't know yet, but at one point I would like to meet them and actually understand better what is their approach. So in these 2 days you saw a selection of people that already are my friends and already I know their work quite well, and their work was part of my really long lecture, and some of them I wanted to meet. So that was the main reason why we organized this, so that we can meet, and Gilles was one of those people. And I'm showing pictures of your work in every single lecture. And I have to say that because I collected material for 5 hours lecturing, I counted, I had part of that lecture since those 2 years ago already 25 times. So at least 25 times I was showing your work in my lectures.
So maybe you can do the presentation.
Maybe, but actually the pictures of your work, those were the ones where I said, okay, what I'm going to tell you is actually not, this is not right. This is not what it is. It's just, I'm going to speculate on this. So this time you just are going to explain, and from this point on, I'm going to say it right.
Now I'm really curious what you were saying.
Yeah, well, I was kind of explaining that in the morning, you know. I know, it was rough in the morning.
Okay, I will ask you that question after my lecture.
No, I have to ask questions you know the Q&A, I explained that to Mateusz. They are asking, you're answering. Yeah. You cannot be asking me and answering. Yeah. Anyway, we will have a chance hopefully to discuss tonight or tomorrow morning. I'm going to tell you what was my speculation and what was my wish, and how did I use you to build up my argument. Yeah. I'm really looking forward, and finally I will have a chance to learn what is it all about.
Thanks, that was a nice introduction. I mean, now I'm really curious. But what is actually also quite interesting, I think part of how I'm going to do this lecture is really tracing a move that I made in my thinking from 3 years ago till now. So probably, maybe what you presented 2 years ago, I may have presented my own work quite differently 2 years ago. So, I guess architecture can be this productive lie where you kind of re-engineer things afterwards. Yeah, so for the just maybe a short background. So I'm teaching in the Bartlett in London, and I graduated from the AA just across the street from the Bartlett, and I run my own practice in London, which doesn't really have a name. It's my own name, kind of. And I will be showing, I won't actually show so much work from my students, because I don't like to show a lot of student work. So I'll try to show work of kind of my practice and kind of giving a bit of provocations and a bit of context for the research. And just 3 weeks ago, I was asked in the Bartlett, we run this lecture series which is called Plexus, And Plexus is in many ways an event that is very similar to this one. So the idea of the Plexus is that we bring people from very different backgrounds together, just people we want to meet, friends, like a very kind of similar initiative to what Jan is doing. And we'll probably invite almost everyone who was here today will somehow get an email to come to the Plexus and present their work. And so the Plexus was started 3 years ago. And 2 weeks ago, they brought back together people that were presenting 3 years ago. And they asked them, what did you actually do in the past 3 years? And how do you reflect back on the work you were presenting 3 years ago? So that's a screenshot of a lecture I did 3 years ago. I'm 3 years younger and a few kilos lighter, and I have glasses there at the table. And back then, I basically just graduated from AADRL, which is very much a program that is kind of rooted in the idea of digital architecture, right? So it's kind of the program that has been pushing ideas of how we should work with computers. It's very much it's a bit like a mafia. It has quite a strong impact on you afterwards. It creates this kind of community of people, which you may know. And then after graduating from DRL, there is this kind of weird thing happening that I had the opportunity to start teaching, which allowed me to also at the same time start my own practice, and also confronted me, because I started to teach in the Bartlett, with the issue that I couldn't do the same thing we were doing in DRL. So things had to radically change, right? And so this is kind of a post-engineered diagram of some of the projects, like a selection of the projects I've done in the past 3 years with my practice. And they're kind of in this diagram associated with paradigms that I was thinking about or that I was confused about at the time. So just to kind of briefly go a bit through these paradigms. Okay, so I was educated to believe that if you want to use computers in architecture, you have to do continuous, you have to follow a continuous paradigm, you have to do generative stuff, which is very roughly a lot of the presentations today, right? So after going from DRL, so the DRL project is on the left, and then I moved temporarily to Hong Kong, and I collaborated with a friend there. We did this project, a competition project. That competition project is very much a translation of the project on the left into a building. So it's following an idea of continuity, where you establish some kind of condition, and then you have a swarm-like amount of pieces which start to follow that condition. Then, like after I got back from Hong Kong, that was 2012, there were all of a sudden all these kind of rumors coming from across the pond, from the Americans basically, who started to be obsessed with the idea of the object. And that's very much a project, I believe, that started as a reaction to continuity, right? So, whereas there was basically people saying, okay, let's suppose the idea of the network, let's suppose the idea of emergence, the idea of the generative, and let's just talk about objects and not anymore about process. Let's kind of talk about the final object. And it's kind of connected to people like Graham Harman and that I have a more philosophical framework to understand the object. And so this was kind of a trigger for me to start to say, okay, why not, right? I mean, I don't know what to do anyway, let's just do objects, okay? Let's just drop kind of continuity and start to investigate things that are more discrete, without really knowing like why that would be a good idea, but you have to do something. So these are kind of two projects you can find out more about. I'm not really going to present those, but that was kind of my triple O year. So I had 1 year of triple O, 2012, 2013. And then after the triple O year, so these are kind of typical buildings which articulate as masses, which are disconnected from the ground. Where's the time? Ah, there's the time, okay. Anyway, so after that year, I did a lot of work with my practice and a lot of competition proposals, which started to move away from the idea of the idea of the object and start to articulate things much more, at least as a massing, as something that is more kind of flat, and is getting a little bit more going away from this kind of misreading of the object as a mass. So the kind of two projects from that time that were important is the one on the left, which was a competition where I kind of won the competition, and the one on the right is a proposal for the Guggenheim. And then the last series of work are kind of these ones, which are really looking at a single part, a single element, and a serial repetition of these elements into assemblages. So the kind of keywords there are like discreteness, seriality, assemblage. And so for the moment, this is still driving the research. But so I want to cover kind of like why I went from the model on the left to the model on the right, because after 3 years, I found kind of a more deeper reason why I believe the model on the right is much more interesting than the model on the left in this case. So a model from fundamental continuity to a model of complete discreteness. So a little bit about the DRL project. So that was 2012. That was before the 3D printing hype started. No one was 3D printing back then. It was there wasn't this kind of like 3D printing will save the world narrative that is going around in the media, etc. And so we were like, okay, why don't we propose a 3D printed house as a thesis project, and also try to make that a bit of a business. So we got a sponsorship from Materialize, from a big 3D printing company. And we kind of developed this this exploration of if you would actually be able to 3D print an entire building almost at once, what are the constraints that still remain, and which kind of project could you do? And in many ways, like the algorithm that we developed for this project was very much based on that kind of generative paradigm that we were taught in DRL. So it's the idea that all this material starts out in a generic condition, and then it starts to organize itself and cluster together and kind of bundle in response to like a field of forces, etc. And we did start to take into account some ideas of production. So the idea that you wouldn't actually, we would actually print this in a factory in a larger kind of chunks, and then ship those chunks in pieces to site and assemble it together. These were some of these pieces we got from Materialize, and then when you assemble it, you get you don't actually articulate the discreteness of these pieces, but it becomes this kind of continuous building where every piece of material is supposedly optimized for its local conditions. So. And then this project kind of translated into the teaching in the Bartlett, where the Bartlett bought a lot of robots, and they needed a lot of young people to start to play around with those robots. So with the students, we started to question, like, if we would actually have to manufacture this building, how would we do it if we wouldn't have a company sponsoring, and if we have to invent those machines ourselves? So we just use the robots not actually as robots, we use them as 3D printers. So we probably misuse them. It may hurt Johannes, but we don't use them as robots. We just use them almost in XYZ, okay? Yeah. So we kind of use them as big 3D printers. And then we started to you know, after a few months, we were able to like print these larger chunks and pieces, and it's really fast, it's quite cheap. And like this project, that's the kind of first generation output from that work, and it was very much based on the same continuous paradigm. So the idea is that this was generated with a kind of agent script which would draw traces, and then these traces would be translated to robotic toolpaths, and then none of these robotic toolpaths work, and then you need students to debug and plan and like manually edit all those toolpaths until it works. And they, of course, would never mention this, and I would also not mention it. I would be like, hey, this is generated by this script, and everything works, and you press a button, and you have all the toolpaths, and then we can 3D print this pavilion. But what we learned from this project is then, after this was done, we were like, okay, so actually that idea of using a continuous computational method to generate toolpaths for a robot is incredibly tedious, and it doesn't work. Because there's such a high degree of differentiation in this structure that it will need an incredible effort to debug those structures, and you would need to start to work with sensors, and you need to develop a lot of algorithms to kind of post-rationalize your work. So we started to work with that idea of discretizing the toolpath in the next generation of work. So instead of working with agents, we had a much more kind of harsh approach to organizing toolpaths. So we basically just create one voxel, we put a piece of a toolpath in the voxel, and then we let all these voxels just with like local rules construct continuous toolpaths. And then if you let this run after a while, you have just one simple toolpath, and if it works in one voxel, it will also work in 40,000 voxels. So if you solve the problem in one stage at that discrete element, it's very easy, and the students could go have beers, we could go to parties, and it worked much better. So I'm just going to show like really briefly a video of how this works. Oh, it has music. Okay. I don't want the music actually. How do we switch off the music? Okay, perfect. Okay. Yeah. Okay. Sorry, guys. Yeah. So basically, what the students did, they took the initial Panton chair, and then they kind of analyze the distribution of loads in the Panton chair. They voxelize it into a series of pieces, and then for every voxel they can calculate the toolpath. I'm just going to go like really briefly over this so you get a bit of an idea of what we're actually working on. And then you would translate those toolpaths to the robot, which is just acting as a 3D printer, and it would kind of like in kind of a day it would output a chair. I just go to the yeah, and the students, like, this is actually nice. So the students are like standing there on the background while their model is being fabricated. So we made these kind of different iterations of the chair, like slowly optimizing it so you could actually sit on it. This was the lightest student we could find. But you can, I can also sit on it. It's actually fine. Yeah. So that's kind of just a part of the research in the Bartlett. Okay, back to here. What was it? Control L. Oh, I'm printing. Sorry, Control L. Okay. Okay, so yeah, this is basically these chairs, a series of chairs. This is a similar process we used to print in concrete. So we printed this concrete table. But then we started like thinking, okay, it's kind of interesting that we're using a discrete computational process, which has a lot of advantages for us. But what if we would actually also use a discrete fabrication method? And we were inspired there by Neil Gershenfeld, who was mentioned before by Aldo in the lecture. So Neil Gershenfeld has this kind of definition that he says that actually all the rapid prototyping machines we have, like CNC machines, 3D printers, they are actually analog processes. They are continuous analog processes, which continuously extrude the material or continuously remove a material, where we don't actually have machines that are fundamentally digital. So we don't have processes which are working in the same way as our digital method. And so this is kind of the provocation then to say, like, actually, what is the fundamental difference if you delete the process? What is the fundamental difference between the thing on the left and the thing on the right, right? And there was also a little bit a sense of frustration when we had this chair printed. I mean, it's just a bunch of plastic wires in a nice form, but fundamentally it is actually a kind of very old process, right? And I would try to argue that the thing on the left, the robot 3D printing, I'm deliberately switching, right? So the left one is 3D printing, right? And the right one is manual clay coiling. That actually, in the way how material is organized there, they are just as old, right? And so we started to really pose this question: what if we don't try to mimic this kind of crafty processes that we as humans have been doing for so long, like carving, chiseling, sculpting, adding clay. But what if you start to look at processes that are fundamentally discrete and organize material in a discrete way? Because also, if you think about it, like 3D printing it's actually a really, really kind of old idea. Like this is a Dow chemical. In 1966, that's a little guy like sitting on a rotating chair, and he's like pushing clay through like a nozzle, and then he prints a dome. I mean, that's 3D printing, right? Like, it's not because a robot would do this that this is new, you know? This idea is really, really old, and it's really, really stupid. Yeah? And it also has lots of problems, right? So problems with analog systems in general is that it has structural problems, it has speed problems, you can't do multimateriality, and it's non-reversible. And and also, I mean, essentially, like all these continuous processes, that's basically everything you could argue before modernist assemblages. Everything before was in some way continuous, and at least in the West. And like in a way, they're kind of, you know, it's just kind of a version of a Roman compression-based system. And we're much more interested in the way how the modernists were able to make assemblages and to deal with matter. So the question really became, what is a digital or discrete material organization? And this is the thing Neil Gershenfeld suggests. It's like a called general instructor kit or something. So it's a little discrete piece that could be deposited by a robot or by another machine, and then you can kind of construct anything. And the interesting thing about this is that it's an incredibly standardized thing, right? It's a standardized piece. It's always the same one. And it's just serially repeated. And another example of digital materials is a Lego block. Because a Lego block is fundamentally discrete. It only allows you to connect pieces in a very specific set of possibilities. So the piece itself defines the assembly. You can't like randomly overlap Lego blocks so they don't connect, right? And so then this kind of became the thesis how I started to reinvestigate my own work. So the thesis became that through the power of computation should not be kind of invested in this pursuit of extreme continuity, but exactly the contrary. So what we can actually do is push the modernist understanding of architecture as an assemblage of prefabricated discrete pieces into a whole new domain, right? So essentially this in a kind of very ugly diagram, this is kind of what I'm arguing for. Like let's just look at the modernist model, which has prefabricated pieces that are discrete, and instead of thinking about them in a typological way, so instead of thinking about them as columns and as slabs, let's just think about a generic piece that has no meaning and kind of no content that we can use to reconstruct spaces, and that can, through the scale and the way how you organize them, can achieve these ideas of maybe, you know, another kind of space than the modernist one, which is more adaptable, more heterogeneous, which can also better deal with multimateriality, etc. There are some machines, like unexisting kind of machines that do voxel assembly, like this one. And it's really this kind of world which is between top-down pick and place and self-assembly. So self-assembly is a little bit too magical and too slow. We are very interested in this kind of rapid assembly, like very quick processes that can assemble discrete pieces. And this is like just a brief overview for those of you who are familiar with people like Mario Carpo. He wrote this it's not in here, okay. So basically Carpo divides the digital age into different eras. He has the first digital age, which is with people like Greg Lynn and early Hani Rashids. And he's saying that is basically people using computers in an analog way. So they are using the computer to make a virtual version of like claying or like sculpting objects. And then they also fabricated in an analog way. So they were not actually using computers as computers. And then the second digital age, according to Carpo, is people like Alissa Andrasek, Hans Meyer, Philip Morel, which are using computers in a digital way because they use them as discrete systems, but they still rely on analog fabrication to realize the objects they are making. They're basically 3D printing or slicing their stuff. So the kind of logical conclusion, even like the logical conclusion to play out would be, what if you actually align the digital both in computation and in fabrication? And this is something we're doing right now with the Bartlett students for this new generation of research. I'll briefly show you something, but they just started, so we don't have so much yet. But I'll just show you how I'm trying to do that in my practice. So my practice, unfortunately, doesn't have these cheap robots. They're a little bit too expensive still, yeah. And it's kind of practice work also engages some level with clients, etc. So this is kind of set in another environment in academia, right? And so the first project is the log cabin or block hut in Dutch, and it's kind of understanding, in a way, it's kind of a reference to also the discrete nature of these log cabins, which basically through these connections establish some kind of discrete and digital organization of pieces. It was initially a project for a friend of mine in Belgium who also studied architecture, but he became kind of more interested in sustainability and like the more less exciting parts of architecture maybe. So he also had much more money than me, so he asked me to design his house. And so the idea with this house is that this is kind of a differentiated, quite heterogeneous and quite kind of maybe unique space, but the idea is that you would only make it with this brick, nothing else. You wouldn't have to CNC mill anything, you don't have to customize anything, no mass customization. It's just one piece, always the same piece, and you just repeat it again and again and again, and you try to be really smart in the way how you organize a piece. Which is an economic argument to convince this guy to put money into this thing, right? And so it started out with this kind of series of more like graphic explorations, how you could do this. And obviously with this one piece, for the moment, that didn't really work. So I needed a 5% zone of customization or customized pieces, which would allow 90% of repetition or 95% of repetition in the other parts. So basically what you see here, it's always a repetition of the same thing, but then in the corners and in the kind of junctions, you need a customized piece which can negotiate the different directions laid out by this generic piece. So it looked a bit like this. It was also deliberately designed as a non-generative and non-morphogenetic project. A morphogenetic approach to this building would be that you would not have, for example, these columns here, but you would try to like bring down the same stones to like take care of the forces there. And this is kind of introducing more like an ecology between the columns as pieces and then the other discrete elements. And then I actually wanted to make this a bit more convincing as an argument, so we decided with the practice to build a model, a big model to test this principle. And so all the red zones are the customized zones, which were, for the model, we 3D printed those pieces. In reality, you would just cast them. You wouldn't have to 3D print those. And then all the white ones are the repetition of tiles. So the people who were working with me, unfortunately, had to cast 5,000 tiles, which was a very tedious, like Marx would say, like an alienation of the worker with the product he produces. Like it's not a lot of fun to make those bricks anyway. So it's really kind of suggesting a model that would look a bit like this here, right? And then you would add those pieces on the customized ones, and these are kind of chunks and things coming together. And then when you add all these pieces together, you get something that is quite differentiated, is able to negotiate different spatial conditions, and can also expand and contract and be adapted at will. So that's kind of a model that is 2 meters, like kind of, yeah, this big. The columns had to be thicker than I wanted. And then the interesting thing is also that piece essentially removes the discussion from formal articulation and from the kind of agenda of space. And the idea, like in the 90s, it's all about like trying to understand how the floor maybe merges in the wall and how you kind of articulate and model space and sculpt space. These pieces don't contain any definition of space. They are just like literally voxels. And you can do with them whatever you want, right? So you could design a building that is really just kind of more maybe based on a column beam grid like this one. Or you could articulate it much more as a kind of a funky atrium, which is maybe in formal language closer to the digital project. That's a table prototype from the same thing. And then I kind of explored this on a series of, was doing this competition in Vienna for the Karlsplatz, but I didn't have enough time, so I just decided not to hand in, but make 3 versions of the same building, and just kind of explore different possibilities. So this is kind of another articulation with the same piece, which articulates as this kind of different slabs and then a column beam organization, kind of you know, a non-hierarchical stacking of space, and it also introduces this kind of color gradient, and it's really just that kind of repetition of that one piece and then this 5% customized zones. Then I also applied this for a master plan in China, and in this case, I did this kind of a weird thing that instead of kind of analyzing the master plan using agents, etc., I just copy-pasted the same building twice, right? So I just kind of mirrored it. And it also has this kind of weird resonance. If you've been to like China and Asia, it has this kind of weird resonance somehow with the kind of traditional Chinese architecture, which has always been fundamentally discrete. Like this is actually quite interesting from a more cultural perspective. So in the West, architecture has been, until modernism, I would argue, been defined by an idea of continuity, whereas in the East, they only invented one architecture once, which was like 2000 before Christ, and it has always been the same architecture, which is a discrete log cabin style of organization. And then this is just another exploration again of the same project, where kind of looking how you could go from this slab condition into kind of atrium-like condition, and yeah, kind of really the negotiation between this horizontal plane and then a vertical plane. Yeah, with this articulation of beams. And then after that project, of course, the weakness in that project is that it still needs this customized zone, right? So I wanted to get rid of that idea that you would actually still need that, continuous zone to be able to establish this heterogeneity. So the next projects were like quick investigations into the idea, what if we really only have one piece of matter that constructs this heterogeneous conditions? And so that piece is just, it's a cast hexagonal section, and this is some form work and some experiments we're doing with concrete for those things. And then when you put all of these like hexagonal sections together, they can slide. Then you get this kind of almost natural generative looking like structure, but it's 100% based on the serial repetition of the same component. And that was kind of a wild sculptural investigation of how this space would look like and what the kind of qualities are of these structures. And then that's another version of the same competition at the Karlsplatz in Vienna, where you get an articulation of these pieces but on two different scales. So here they're kind of thicker, and then these white ones are smaller. And so that was a really kind of interesting moment then when you look at this thing and you question, okay, if we can actually establish a language and a lot of conditions which somehow are taking into account this basic premise of the digital, which is like a certain, a certain amount of resolution, a certain amount of adaptability, differentiation, etc. But you can actually do it through serial repetition. And then the kind of the last iteration then of this work is just based on it's not really finished. I'm working on this one now. It's kind of looking at a square section for the piece, which can establish, it can negotiate again these three axes, right? So vertical, horizontal, secondary, etc. And it has this ability for multiple scales. So basically you have like larger pieces and smaller pieces, and the connection is also standardized. So the intersection of those things is always exactly the same. But that's kind of ongoing. So you can follow all this work. I always kind of update everything at the same time. But I want to briefly show you to give you an idea, like, although it's work in progress, of what my students are doing at the moment. This is really rough work. Like, it's really, half of it I don't like, but it's just to kind of show you now how this, in an academic world, how this would translate. So basically the idea is that now, instead of using the robots to extrude material, we want to use the robots to basically assemble small particles or small building blocks into these heterogeneous kind of structures. And we don't want to use the robot as a robot. We don't want to use it as Grammatio Kohler does assembly, right? They take bricks and then overlap it, or they customize beams and then put it together into a structure. because we're a very small research group in the Bartlett. We don't have a big budget. We work with students. We don't have 5 PhDs to work for 2 years on the timber assembly. So we want to do really quick, super fast, simple assembly processes, which means that the robot can only move in X, Y, and Z. Just pick up, deposit. And so this is just, I'm just going to flip through this thing. So this is our students looking at establishing that simple piece and looking at how they can compute these pieces and how they can how they can establish heterogeneous conditions with these things. This is kind of looking at shifting really between like a voxel logic and another logic, a tile-based logic. This is, I don't know what that is. Okay. This is really ugly. Don't look at this. Sometimes they do terrible things. You know, it really takes a year until there's something nice going out. But so then they're looking like, for example, this is another version of those chairs, but this chair would be then completely assembled out of like a repetition of those pieces. So for the moment, we're really looking at systems for how we can actually lay this out as a production system. So how do you have a robot pick up those pieces, assemble it very quickly, and yeah, I hope to show you probably in 1 year the first kind of output of that research. Yeah, thanks. So now my big question is like, how would you present the same work, right? That is kind of.
No, you cannot ask questions. You have to answer.
Okay.
But seriously, now it's your turn to ask questions.
I have a curiosity. Did you also investigate how you might close these spaces with some glass elements or something?
Yeah, there would just be a glass facade. Yeah. Yeah. Yeah, it's just literally glass. Yeah.
So, no, because maybe you might want to make like a module of glass and follow similar logic rather than try to make some custom.
Yeah. No, but I have this kind of weird things for the moment that I kind of insist on. So I insist not to design the stairs. Like all the stairs are kind of standardized stairs that are not designed with the system. And also, I don't design the facade. So I don't do any facades for the moment. Because I think, I mean, like all the projects are really about kind of the bones of the architecture. Like really it's not really interested in architecture as a skin. So like that's why there is no, essentially there are no facades there.
So this is rather the structure.
Yeah, exactly, yeah. Yeah.
I mean, yeah, great work, congratulations, but for the move, coming back to the screen, I think it's highly important, like, to address this again.
Mm-hmm.
I mean, when we talk about assembly, or remember, like, beginning of Greek temple, the array of columns, it goes around the corners sooner or later. And the latest project, and you remember, like MEES, like every project has a certain corner condition, the corner problem. And you specifically avoid this.
Mm-hmm.
You avoid, I think it was like, I mean, I see like you had this one progress from the block hut. You talk about the 5% customized, which are the corners. And then later, like you take them over the corners, the elements. And I think what's it leads to another question like how you address the whole or the whole figuration instead of what they assemble. So do you ignore this, or like is there what kind of agenda? I mean, you make it not just because you forget it. So like.
I mean the corner, yeah, like I think like this is a good image probably to look at those corner conditions, right? So some of them, like this one, is actually, I would argue, like that, like this one is kind of would need a customized part here. Like this one is not actually solved, and that's kind of how the corners would look like in with these discrete pieces, which is effectively, like you're saying, it's kind of the non-existence of the corner. Right? There's absolutely no corner, and the same probably in these ones. There's probably also no corners. Yeah, I mean, I would say it's quite interesting to think if the corner is per definition a continuous thing that would actually disappear with those projects.
In a continuous way, when you remember John Bouvet, he's just bending it around the corner. But then all the other projects which are like minimum based on a grid or placing in a regular thing or like assembly. The main issue then is always the corner thing.
Yeah.
How you all, this then also addressing the envelope.
But I think like that's actually maybe a good way to understand. It's like it's definitely abolishing that idea of the corner, which maybe you could relate to the fact that all of those projects essentially they kind of blur the figure. Like essentially these things don't have a defined figure or a defined outline, right? They are kind of, the outline is kind of almost a byproduct of the assembly of those things, which is the same as with that corner here, right? And it also has something to do with the fact that all of these buildings, I think, almost as a quality, have something that they seem to be kind of eroded or cut out. Like they don't actually have an end. Like you could, in principle, in the block hut, for example, you could just add another series of pieces to it if you want. They're kind of indeterminate in their final shape. And it's almost the same with this thing. You could kind of continue it if you wanted to. So they're always in this kind of stage that there is no defined figure and there is no kind of, you could almost argue that, you could almost start to question how much there is actually a hole in those things as well. Yeah. Ryan?
I'm trying to...
Oh, no, there's a non-Ryan person asking a question. Yeah.
Yeah, I think your projects are very beautiful in aesthetic view. I always wondered about, it looks like you're using very much amount of material. So did you always consider sustainability? Because you
I mean that's actually that's a question I'm really struggling with for the moment. Like the problem is like for example this next version, like this one is really meant, that's something I'm developing for an actual project, and it doesn't make any sense, right, in terms of material, because you don't need so much beams and material to create a slab. Like it's, you know, if you look at a timber structure, it has really large gaps in between the pieces. So if you have any suggestions how I can sell this, they're really welcome. But I mean, like for the moment, my kind of take on this is the argument that maybe not all of those pieces are actually structural. Like some of them may actually be like a cladding or something. Like I don't know. I'm trying to figure that out, how this would work. Yeah.
But you know, there has been an expo pavilion in China. They have doubled the construction structure because of the price of the steel, that they can resell it more expensive. So maybe you should think in this direction. There is no oil, so...
Yeah, it's just like a storage for capital, basically. Good idea. Yeah. Okay. Ryan.
So you make the point that very much so, it has the sensibility of the discrete object from China, and it reminds me, just thinking, one of the points you made was that the continuous printing and continuous project, there's no disassembly. And I'm curious on how you would, because you think about the, what is it, the White House, the White Chapel in Japan, where they would
they continuously refurbish it. Yeah.
So how would you see, in a certain sense, these things don't look like they disassemble?
Well, they're meant to be. I mean, as a productive lie, I would say they are. Yeah. I mean, because that is definitely part of the argument, right? So part of the argument, I mean, the core difference between digital matter and analog matter is the fact that you can assemble, reassemble, and reconfigure it. And basically that means that the part is not domesticated by the whole, right? So the part is a generic piece which has no content and no meaning, and it's through the assembly in a specific structure that where the kind of meaning emerges, right? And so it's really essential that a part is generic. Yeah? And I mean, I would argue, like, actually, so these Chinese and Japanese temples, they are actually discrete architecture, so it's highly computational as a principle. And although they didn't use any computers to make, I mean, it's not computation, they are digital, but they're not made with computers, right? And those things, yeah, they have that idea of continuous reassembly and updating of the parts, which is also the core argument of Neil Gershenfeld, why they developed these generic building blocks. So that's developed for the airplane industry, which is one of the most continuous industries. So you need, like, to make an airplane, you try to make it as continuous as possible, which makes it incredibly expensive to replace parts because you need to strip off holes, right? And so his argument behind those pieces is that you could easily replace those pieces and you wouldn't need continuous surfaces. Yeah. But I mean, for the moment, it's really like an exploration, right? It's kind of a wild look into this world, and
The newest one, though, I guess it does answer my question. The newest block of our project that you did with students, which is very nice, but I showed these to my students as well, so I have one student that's struggling with it. I haven't shown him yet. But, yeah, I think I would like to see one of the triple layers disassembled. I think this is my curiosity.
one of the?
The triple layered ones,
Yeah.
almost just to see the process of it.
Yeah.
And like, I also am just curious, how do you get to the side?
Because
what does the blocks look
like the reversibility thing is really something we want to push with the research in the Bartlett this year. So it's like, for example, my students, what they're doing now is they make 2 chairs and a table, but you can make the table with the 2 chairs. So you so you kind of reassemble it into another structure.
Truly,
and they would have to show that, like they would actually have to do it.
I mean,
Yeah,
that's like,
absolutely.
yeah, I know this pattern you showed too. This is, our friends, others are into the same thing. We talking about here, and it's truly the way we need to push it. It is.
Thanks, Ryan.
So you were saying, you were talking about the 5% which would need to be customly produced in order to be able to plug in the, let's say, component, right? But in the last project you showed, like this competition, would this custom-made components be required for each, let's say, intersection point in your structure?
Oh, this one?
Yes.
Okay, yes. So this one or the other one?
Actually, it applies to this one as well.
I mean, like the idea with these ones is that they don't actually have any customized pieces, and obviously, like this one, it isn't worked out yet. But actually, the next iteration, I don't have the image here, but the next iteration is actually taking into account the intersection as a connection, because for the moment, the connection between those pieces is straight. But if you make that angular, you can always connect to every beam because it's always the same angle. So you don't need customized.
But I was also referring to the like where the
This
horizontal meets the vertical.
Sorry?
Where the horizontal lines meet the vertical. How are you going? I mean, do you think about that, or I mean, how are you going to tackle it in order to not have customized?
I mean, I'm pretty convinced that this one I can do completely without any customized pieces.
Okay. No, because I was just asking because at the moment they're just going
Yeah.
through,
No.
so that's why.
Yeah. It's not ready yet.
Yeah. I really.
Yeah. Okay.
I don't really want to cut you off, but
You will. Okay, perfect.
Thank you very much for an amazing lecture and for waiting so long until your time came.
No.
This was it. This was the final lecture. Thank you again.